you can't really do. Can you do that with physics? Really?
Well, you can if you're not pompous like you are.
No, but it's harder because everybody's looking up.
Yeah.
And when we discover
more
like a
relatable, what you
supernova, a black hole, anything, it's headlines.
Yeah, splitting an atom is less relatable than looking up at the stars.
How many other sciences make a headline with that frequency? Think about it.
Yeah, that's true.
Yeah.
It's
And
relatable.
how many families own their scientific instruments that they use professionally? Like people buy telescopes.
Telescopes.
Right. Yeah.
So that's what I'm saying.
Yeah.
So good luck with that. Sometimes you need a little bit of that, but
absolutely.
You're at the helm of a very important organization.
Thank you, sir.
And there it is. So now tell me about the latest NASA acronym.
Yes.
Interstellar Mapping
and acceleration
probe.
But you can't have a thing that says IMAP and then the word mapping is in the middle of it.
Yeah, that's bad.
It's not working. We're going to have to redo this.
The word in the acronym can't be in one of the words of the acronym.
It's like GNU's
Look
not
at this, Mr. Smart Aleck over
Remember?
here.
GNU's not Unix. GNU.
Oh yeah.
GNU,
right.
Linux, Unix. You guys aren't that old. Okay, never mind. It's the white hair. So here's the thing. Before this,
he's not nerdy enough.
I was working on a satellite called the Supernova Acceleration Probe, and now I'm working on the Interstellar Mapping and Acceleration Probe.
Well, no, you're working on Earth. Related to the probe.
Right.
Working on
I
the probe.
just used the word on.
Yes, you did.
Okay.
So
this is awesome.
So why is the word acceleration in the probe?
Because essentially what happens is the sun accelerates particles, right? It creates this bubble. And the example...
That's the solar wind.
The solar wind,
Yeah.
right?
So the heliosphere,
but it's moving
right?
fast. It is supersonic,
Right.
The heliosphere.
Yeah.
But when it hits
Wait. What do you mean supersonic if it's moving through the vacuum of space?
Space, is it exactly a vacuum?
Oh, it's approximately a vacuum.
It's approximately a vacuum. Yes,
Okay.
it is. Yes, it is.
Okay,
yeah.
so cool. So it's moving faster than the speed of sound would be in that very reduced vacuum.
Exactly. And what happens is that, so it's almost like a boundary where information only travels one way, which is out.
That's the heliopause, isn't it?
No, the heliopause is what I'm getting to.
Okay.
So just like the example that's given is when you
Stop
run
showing off how much
water.
you know.
I know, right?
Let him catch up with you. And then,
Where do you find these two comedians?
I don't know where I get 'em.
These guys know more science than me.
I'm done. That's the only thing I know.
You know how you
we got to
run water?
lobotomize him first before we put him in.
You know when you run water in a faucet and it makes this, and then there's that ring?
Yeah.
Right, that's like the heliopause where it goes from supersonic to subsonic.
Right.
So our heliopause is doing that in the interstellar medium, but here's the thing. There was a previous satellite, so the guy who's running is professor out of Princeton named Dave McComas, okay? So I don't know if you remember the Ulysses satellite
Yes, I do.
that went over the pole.
Went to the sun, didn't it?
Went to the sun.
Yeah.
Went over the poles of the sun, and we got to see that the solar wind around the mid-latitudes, you have the regular wind, 400 kilometers per second. Out of the poles, the highest speed